Here we're going to solve a quadratic equation by completing the square, and in this case the coefficient of x squared is not equal to 1. So the first thing we have to do is make sure everything's in descending order and equal to 0, which we have here. So we have the x squared term, the x to the 1 term, the constant equals 0. So that's all set. The next thing we want to do is get rid of this coefficient of x squared. We want just a 1 to be there so that we can complete the square process. So I'm going to divide a 3 from every term in the equation. Alright, so dividing 3 on both sides of the equation, we get x squared minus 4x plus 11 thirds equals 0. And now we're at this stage where we want to move the constant term to the other side by subtracting it from both sides of the equation. And that gives us x squared minus 4x, and I'm going to leave a big space here for completing the square, and that equals negative 11 thirds. And now we want to add whatever is necessary to get a perfect square trinomial on the left side, and then we'll balance it by adding the same thing on the right. And that's why this is called completing the square, because we're making a perfect square on the left. And we can use the exact same recipe every time for what needs to be added. Always add 1/2 times the coefficient of the x term, so half times negative 4 squared. And in this case that would be, and think of this as negative 4 over 1 if you like to see it as a fraction. 2's will cancel out, so we're going to get negative 2 squared. Negative 2 squared is 4. So we add 4 to both sides. And now we have a perfect square trinomial. So we can factor the perfect square trinomial by doing the square root of the first term, so that'd be just an x, square root of the last term, so that'd be 2. Keep the sign of the middle term, so keep the minus sign. And off to the side you can always check it to make sure it really does factor properly. Just check that you multiply it out, you get the original expression back. So x minus 2 squared is x minus 2x minus 2, which gives us x squared. Minus 2x is minus 4x. Minus 2 times minus 2 is plus 4. And yep, that's what we started with. As long as you use this recipe right here for building or for figuring out what to add to both sides, you will have a perfect square trinomial, and this factoring method will work. And that equals negative 11 thirds plus 4. So let's play around with that a bit and simplify it. If we have negative 11 thirds plus 4, that's the same as plus 4 over 1. We're adding fractions, so we need common denominators, so I'm going to do times 3 top and bottom on the second one there. And that will give us negative 11 plus 12 over the common denominator of 3. And that gives us the right side of the equation. Negative 11 plus 12 is 1/3. Now we have a quantity squared equal to a number. So that means square rooting both sides. Putting in the plus or minus option. Really important not to forget that. That means we have x minus 2 is equal to plus or minus the square root of the right side of the equation. Now let's simplify this right side a little bit. This is the same as x minus 2 is equal to plus or minus square root of 1 over square root of 3. And the square root of 1 is 1. So x minus 2 is equal to plus or minus 1 over root 3. And to have a simplified fraction, we don't want to have a root in the denominator, so we're going to rationalize the denominator by multiplying the top and bottom by root 3, which gives x minus 2 is equal to plus or minus root 3 over, and root 3 times root 3 is root 9, or just 3. And now all that's left is to isolate the x. So we're going to add 2 to both sides of the equation, and we get x is equal to 2 plus or minus square root of 3 over 3. So that's one way to show the answer, or we could show it as one single fraction. So we could show it as, if we take the 2 plus or minus root 3 over 3, think of the 2 as 2 over 1. Common denominator will make a 3, so times 3 times 3, which means we have 6. X equals 6 plus or minus root 3 all over 3. So these look kind of different, but they really are the exact same answer.